Swifters, it's not Professor Oak, it's not Professor Elm, it's Prof G, and we're going to start to build our Catch-em-all app. In this first video, we will learn to get the first page of 20 of those wily characters from anime and video games, and we'll use the popular Pokey API to do it. Then, we'll learn to work with Paged JSON so that whenever we run out of data, we'll load in more until we've gotten all of the data available, or in this case, until we catch 'em all. One quick note, on the very day I prepped this video, the Pokey API switched from tracking 964 creatures to 1,048 creatures. You might have even more in here depending on what's available in the API when you go through this tutorial, but regardless of the number of those wily monsters, the techniques will work. Are you ready to head to the Swift Gym? Then let's train. This is a tutorial for beginners, but many of the concepts were covered in earlier videos. This is Chapter 7. You'll find the other chapters on the YouTube channel with reference material in our textbook. Since we've already covered these concepts, if you want to issue yourself a challenge to make sure that you know how to set things up on your own, feel free to. This is what we're about to do to get things rolling, so if you want to check out this slide as a challenge, you can go and follow these steps. You can pause, try this on your own, and resume when you're ready to go. And as always with our challenges, we go through the solutions step by step after them. Let's start as we always do by launching Xcode. We'll select Create a New Project, Single View App. Next, I'm going to call this Catch 'em All. The language is going to be Swift. The user interface is Storyboard, not Swift UI. Click Next, then Create. Double-click the title bar to expand Xcode to full screen, and we're ready to begin. And you know what? Our default view controller is called View Controller. I'm going to show a list of Pokemon, so let's rename this List View Controller. So in the Project Navigator, click on ViewController.Swift, then highlight the name View Controller in the class definition line of your code, right-click, refactor, rename, and we'll change this to List View Controller, upper camel case. Then I'll highlight the name, copy it, and I'll paste it over this comment up here just for consistency. And then we'll head back to the main storyboard. Let's embed this in a navigation controller. To do this, I'm going to click on the yellow circle in the dock at the top of the view controller. Then I'll go down to the lower right-hand corner. I'll select the Embed In icon and select Navigation Controller. There it is. And now let's add a table view. We'll click on the plus library icon. We'll search for table view. Don't select cell, don't select table view controller. Then click and drag the table view onto our view controller, release. And with it selected, let's head down and add new constraints. That button's in the lower right-hand corner. And constrain this at 0, 0, 0, and 0, top, left, right, and bottom. Make sure each one has a red indicator line indicating it's set. Your button should say add 4 constraints, and click that. Now with the table view selected, let's open the attribute inspector and increase the number of prototype cells from 0 to 1. There's our cell. So now let's click on that table view cell, and you see it's highlighted over here in the document outline. You want to make sure that the table view cell is selected. Then over in the attributes inspector, let's set the identifier to cell. That's capital C, lowercase ell. And with the table view cell still selected, let's change the style from the default custom to basic. And we can see that now we have a label in the cell with the placeholder text title. Let's change the font to that label. So just below the cell in the document outline, I'm going to click on the expansion triangle next to the content view. I can see the label with title in it. Just below that, I'm going to click on that label to make sure that it's selected. And then in the attribute inspector, I'm going to change the font for that label. I'm going to set the font to custom, the family to Avenir Next Condensed. I'll keep the style at regular, but I'll change the size to 20 and click done. Then let's see, I also want to make sure that this cell doesn't keep its gray selection indicator once the user clicks on it. So I'm going to go and select the cell again from the document outline, and in the attributes inspector, I'm going to change selection to none. And now we need to add an IB outlet for the table views. So I'll click List View Controller in the Project Navigator, Option click back on main storyboard. We're side by side in the assistant editor, and I'll control drag over from the table view. I'll release it right underneath the class definition line. I always check the type to make sure that I've dragged over from the correct object. Yes, this says UI table view. That's right. I'll name this table view, lower camel case, and here's some quirky behavior that I'll leave in just in case you see this. Xcode is saying it couldn't create the outlet because it couldn't find any information for the class named List View Controller. Now this looks like another Xcode glitch, so I tried a few things, and the thing that worked was I closed my project, I reopened it, and everything worked fine. Hopefully you'll never encounter that, but if you do, now you know how to fix it. Now let's put a string array placeholder with some Pokemon names just so that we can make sure that the table view is working. We'll eventually get the actual Pokemon data over the web. We'll put these in a variable creatures, so we'll say var creatures equals open bracket, and you can put in whatever Pokemon name you'd like. I'm going to put in Pikachu, Snorlax, Bulbasaur, and Wigglytuff. Now, whenever you work with table views, one of the helpful things to remember is delegate data source, delegate data source. So right here in view.load, I'm going to say tableview.delegate equals self, tableview.data source equals self. Then after the last curly, we'll create our table view extension. I'll say extension, and we're extending list view controller, then colon. Then if I do table view delegate, table view data source, I get my UI table view delegate, my UI table view data source, open and close curlies. Xcode will think for a bit, then it will tell me, hey, this does not conform to the protocol UI table view data source. It offers to add the protocol stubs. Xcode, stub me! Click that fix. Then in number of rows in section, we want to return creatures.count, and in cell for row at, we want to first create our cell with let cell equals tableview.dequeue reusable cell. Select this option with the two parameters with identifier and for. The identifier is the string capital CELL. We set that up in main storyboard, and for the index path for for, it's going to be lower camel case index path. That's what iOS passes in when the table view function calls upon its delegate. That's the list view controller.swift file that we're currently editing, and runs this function. Then underneath this line, we'll return the cell, but just above that, we'll also set up the cell. So we'll say cell.textlabel?text equals, and then since we want this to be numbered, we'll put in between the quotes of a string interp index path.row +1, and then outside period, and then another string interp, and then inside we'll put in creatures bracket index path.row. Let's build and run and see how it looks. No errors, hammer time, and challenge 1 done. Nice. Now let's take a look at the data that we're going to get from the web. So we're going to make a call to the pokeapi.co API service. So let's open a browser and head to pokeapi.co. That's not .com, it's .co. And there's documentation that you can read, but let's jump right in and take a look at the data that we want. So I'm going to modify the URL up here in the browser address, and after the .co, I'm going to add slash lowercase API slash v2 slash Pokemon, again, all lowercase slash. Then I'm going to highlight this whole URL that's correct here, and I'm going to copy it with a Command C, because I'm actually going to paste this into my code in just a bit. But now I'm going to press return. The API call is made. We see the JSON that's loaded in our browser. And again, if you followed the weather GIF tutorial, hopefully you did, and you installed the JSON formatter so that you can see the JSON formatted nicely like I'm showing here. If not, feel free to go back and check out the previous tutorial. But a few things you'll notice in this JSON. First, we see a key value called count. Now this lists the total number of Pokemon available to download. Your number might be different, but at the time that I'm recording this, there are 964 Pokemon available. Let's catch them all. And let's skip down and take a look at the results. So we see the results key here. You see this triangle? So we've got some complex JSON after the key value results. Now we can click the triangle to expand or contract it, and instead of results equaling a single value afterward, the value is an array. And we know that because of the square bracket that we see here. We see that each element of the array is distinguished by curly braces, commas separate those curly braced elements, and each element has a name key and a URL key, and both of those point to string values. Now if we scroll down to the bottom, we see we've only got 20 Pokemon, but there's supposed to be 964. How do we catch them all? Well, let's go back to the top. You see how we have a next and previous value here? Well, the next value has a URL. These are strings for the URL that will get us the next or previous screens of 20 Pokemon. So previous is null. That's the JSON equivalent of nil. That means there's no previous value. So we need to remember this, because if we ever try to grab a data structure to hold data that might have a null inside of it, that means we need to record that as an optional. So if we were to keep track of previous, it would need to be string question mark, not just a string. Now we're not going to keep track of previous because we're never going to go back in data, but we are going to keep track of next, and that's also going to be an optional. I'll show you at the very end, at the very last page, we don't have another next page to go to, so that shows up as null. Now we'll see that in just a bit, but for now, let's see what happens if we click on next. Oh, we see the next set of 20 Pokemon. Also, the next URL has been updated to show the URL for the very next page of Pokemon. So if we click that, that'll give us Pokemon number 41 through 60. The previous URL is now the URL where we came from, the place where we started. And just to show you what the very last page looks like, I've got this open in another tab here, and you could find this if you went through and clicked on next 48 times to look at 48 times 20 pages of Pokemon. Pokemon, but here we see in the very last page there are only 4 Pokemon. That's Pokemon number 961 through 964, but more importantly, take a look at next. You see how next says null? So again, we need to save this value because we are going to keep track of next as a string question mark, not just a string. Otherwise, and this is very important to remember in future projects, if you ever try to download a null value into a value that's not expecting an optional, you will get a JSON coding error. So now, something to think about if we go through page after page of JSON. How do we know we're at the end? Well, each time there's another page that will bring us to a valid new page of Pokemon, that next value starts with HTTP. But on the last page, that's not true. So we'll remember that when we finally get to going through pages of JSON. But for now, let's code up a creature Swift class. And for starters, let's just get this count value up here, which is an int, and the next value, which is an optional string or a string question mark. So back in our code, let's put our creatures class just underneath our sceneDelegate.swift. So we'll right click on sceneDelegate.swift. We'll select new file, Swift file. Next, we'll call this creatures with a capital C, click create. Then we can start to code this file with class, capital creatures, open and close curlies. And let's start by creating a structure that's going to help us decode the JSON data that we want. Now, the 2 values that we want are right at the base level of JSON here. So one is called count, the other is called next. So in order to decode this, we'll create a private struct with private struct. And we could name this struct anything, but we'll name it capital returned colon. This has got to be codable, open and close curlies. And then inside we'll put in the 2 properties. That's var count colon int and var next colon string question mark. Remember, how come we need that question mark? Because when we get to the last page, that's going to be null. That's not going to be a valid string. It's going to be read in as a nil value. If you forget to do that, if you hit that null value, you're going to get a JSON decoding error. Now let's create the class properties for the creatures class. So these aren't part of the private struct. We'll say var count equals 0. So what we'll do is we'll take the value that we get at the count from the return struct and we'll put that into self.count after we decode the JSON. And then below that, we're going to create var URL string. And each time we decode a page of data, what we're eventually going to do is we're going to take the value that we get from next inside of our private struct returned above, and we're going to update this URL string with that next value. But for now, we want to put in the very first page where we're going to start to download our JSON data. And so in between these double quotes, I'm going to paste in the value that I'd copied from that first page of URL data we saw from pokeapi.co. There it is. And now let's code our getData function. Now we could actually open up one of the getData functions that you've already coded for our WeatherGift app and modify that for use in the Catch 'em All project, but we'll code this one up from scratch just to solidify our knowledge of what's going on and how to set up a URL session. So the call to this function is going to be the same as all the other previous getData functions we wrote. So we'll say func getData, open and close parens, completed colon at escaping, open and close parens, draw an arrow, open and close parens, make sure you got the closing paren afterward. Completed colon is the flag that we're going to look for inside of this function that says we're done getting our data. The parens and the arrow show that this function has a completion handler at the end. So when we call getData in our code, we're going to use curly braces after the call to add code that we only want to execute once the completed is done. And in those curly braces, this is where we're going to call tableview.reload data after we sure that data has been downloaded and decoded. Now let's open and close curlies and code this function. And a quick reminder on the slide here of the steps we're going to perform when we want to use the URL session to get and decode JSON. We're going to create a URL. We need to do that because a string is not the same as a URL type. You can't just use a string. We need to create a session. We're going to create a data task. This is going to pass back a data response or error. We won't care about the response. We'll check and make sure that we don't get an error. Then we'll try to decode the data that we get back into JSON. Our data structure that we're going to use is called returned. That's why we've got return.self in here. And importantly, we need to make sure that we call the resume method on the data task that we set up so that that executes. Then we'll be ready to call the method in code. Let's code. Now, before we begin, the first thing that I'd like to do is to print out the URL that we're about to use in URL session to the console so that we can use that if we need to in debugging. So I'm going to say print, and then in between quotes, we are accessing the URL string interp URL string. I'll put a web emoji out front. Then we'll create the URL. We'll make sure that we've got a valid URL with a guard statement. We'll say guard let URL equals capital URL, open parens. Select the URL initializer that passes in a string, and we'll pass in URL string. Else, open and close curlies. In between the curlies, if the guard doesn't let us by, we'll say return, and we'll put a print statement above that. Print, error, could not create a URL from string interp URL string, and at the front of the statement, angry emoji. Then we'll create a session with let session equals URL session dot shared. And then we'll get our data with the data task method. And we set this up with let task equals session dot data. And look in here, you want to choose the data task option that's got a URL parameter for width, not the one that's got a URL request. And the completion handler should have the data, the URL response, and the error. So press enter to select that one. Our URL will be lowercase URL. Double click on the completion handler. Our data will be lowercase data. Our response will be lowercase response, and our error will be lowercase error. Then let's first make sure that we don't have an error. So we'll say if let error equals error, open and close curlies. I'm going to grab the front of this print error statement up here, paste it down below, and I'm going to fill out the error with just string interp error.localized description. Then the actual decoding that we're going to do could potentially throw an error. So we need to put that in between do, try, catch. So we'll say do, open and close curlies, catch, open and close curlies. And inside the do clause, we'll say let returned equals try, JSON decoder, open and close parens, dot decode. You have just this one option here that accepts the type that you want to decode and the data that you want to decode it from. It throws, so press return to accept this. Our type is going to be returned. Where do we get the returned from? Oh yeah, that was the special private struct that we created up here. The names of these two properties, count and next, exactly match the key strings for those values inside of the JSON that we're decoding. And when entering the name of the type that you're going to decode, you've always got to put .self after it. And our data is going to be data, and we'll force unwrap that with an exclamation point. Now, just for now, let's print out a statement that says, here is what was returned. String interp, we'll put returned in there, and sunglasses emoji, because this is cool. And now let's take the values that we just parsed out into returned, and we'll put them into the properties of this creatures class. So we'll say self.url string equals returned.next, and look at next in here. Remember, that's the one that's the optional. It could come back as nil. If the JSON we're getting back from the API has a null in it, we'll just handle the potential nil with nil coalescing. So we'll put in 2 question marks and an empty string after that. Then below that, we'll set self.count equal to return.count. And in the catch portion, we'll print out an error. I'll just grab the first part of this error that I printed up here, paste it in down below, but change the contents to read JSON error thrown when we tried to decode return.self with data. And then after the close curly and the catch, we want to make sure that we pass back our completed flag. So we'll say completed, open and close parens. And then after the curly following that, we want to make sure that we call task.resume with those open and close parens. And so with this preliminary getData function set up, let's go ahead and call this from list viewcontroller.swift. Now we'll eventually set this creatures variable up here to an object of class type creatures, the class that we just created. But if we do that right now, we're going to have to change our table view code. But for now, just to get this call to work, underneath creatures, I'm going to say var new creatures equals capital creatures, open and close parens. This is just so that we've got an object created so that we can call getData on it. And then down here in view.did_load, underneath our table view.data source, we can call new creatures.getData. Code completion knows this exists. And for now, we won't even put anything between the curlies because all we care about is taking a look at what shows up in the console. Let's build and run and see what we've got. No errors. Hammer time. Again, we're not expecting to see anything in the app itself at this point, but hey, let's take a look down here in the console. Here is what was returned. Count 964, that's correct. Next, it gives us back this optional string. Now that's already updating for the screen that's going to give us the next 20 Pokemon. We haven't gotten the first 20 Pokemon yet though, so let's head over to the browser. And sure enough, that's our count value, and we got our next value exactly as we see in the browser. Everything's working. So what are we going to do next? We're going to get the Pokemon. We're going to get this array of Pokemon here. It's in an array called results. That's the key name. And each element in this array has 2 keys, one named name, another named URL. The URL gives us access to more information about that particular creature. And so we need a container to hold these values. So in our creatures class, we're going to create a struct called creature. It'll have 2 properties, name and URL, spelled exactly like the JSON keys that we see here. And that'll let us get these values associated with these keys. We'll make sure that the creature struct is codable so that we can use it to parse out the JSON. Then you see how all this Pokemon data is in an array following the key value named results. Well, we need to add a results property spelled exactly the same way to our return structure, and we'll declare this as an array of creature. Now, we're not going to make a creature private. In a later video, we'll actually move the creature struct out of this file so that it'll be a project-wide struct and we can use that in another view controller. But right now, what we're going to do is use it to declare the type for this property of the creatures class down here that we're calling creatures array. It's an array of creature structs, and we'll set this property equal to the results that we parse out using this value here. So hopefully this will be more clear after we code it up and get things working. Let's head back to creatures.swift. So right underneath our return struct, we'll create our creature struct. That's going to be struct capital creature colon codable open and close curlies. We've got two properties in here that will declare var name equals empty string, var URL equals empty string. I could have just as easily declared them and not initialized them. I'm just showing you we could do something different here in this struct. And then we're going to go up top inside of the return structure and we'll declare var lowercase results because that's the exact spelling and exact name of the JSON key that contains the value that we're going to decode. Then we'll say colon, and its type is in brackets since it's an array of the creature struct we just created. Now let's also create a class property using that struct. So down here under URL string, we'll say var creature array colon, and then in brackets that'll also be of struct type creature, and that'll equal open and close brackets, so it's empty for starters. But once we get all those Pokemon named, we're going to be able to display them in our table view. Let's code that. First, the getting results part. And you know what? We've already got our results. We don't need to write any code in order to get the results. That's because the results property is part of this returned struct, which we already got when we decoded the data as the returned struct type, and we put it into this constant lowercase returned. Now let's behold the magic that's about to unfold. Since we've already got that results array inside of this returned constant, we can set results equal to our creatures array, and we'll do that with self.creaturesArray. Look at that type. It's an array of creature structs. Return to select that equals returned dot, and oh, look, result is in here, and look at results. It is also an array of creature structs. Select this, and that's it. You've just parsed out all of those Pokemon names and URLs that were inside of that key array named results in our JSON, and you put them into the creatures array. So once you've got the URL session all set up, all you need to do to get even more data is just a matter of expanding your data structures so you can pour more JSON data into containers that exactly fit the key names and the values that you're going to get back from the JSON. So now let's head over to listViewController.swift and make the changes needed so that we can actually see those Pokemon in our table view. So now I'm going to take this variable named new creatures, I'm going to rename that as creatures, and then I'm going to highlight this creatures line above it that had this literal array of Pokemon and delete those. Then down in viewDidLoad, I'm going to change this reference to newCreatures.getData to creatures.getData. Then down in here in our table view, we've got to update it for our new data structure. So inside of cell for row@, let's see, in this second string interp here, we're not going to be creatures bracket indexPath.row, it's going to be creatures.creaturesArray. Bracket index path.row. And remember, this gives us an element in creatures array, but we want the .name property at the end of this, so make sure that you add that in there. Then up in number of rows in section, we want to return not creatures.count, but creatures.creatureArray.count. And then back up here in our viewDidLoad, we're going to be ready to call self.tableview.reload data. But remember, if we're going to do this inside of a completion handler that comes back from getting data, that happens on a background thread. We need to bring tableview.reload data to the foreground onto the main thread because that's where all of our user interface stuff executes. But we know how to do that. Inside of these curlies of get data, we're just going to say dispatch_queue.main.async. The open and close curly show up, and we can highlight and cut out self.tableview.reload data and paste it in between the curlies. Let's build and run and see if we caught at least the first 20 Pokemon. Here we go. Build succeeded. Hammer time. And slap that Snorlax. When you look at that, we got the first 20 Pokemon showing up. That's the first page of JSON data. Scroll up and down, we see all of those names in here. If you take a look down in the console, we can see that we are definitely getting those creature names and their URLs. But then what we want to do is, after we've got the first page of JSON data and we've displayed all of those Pokemon, we want to get the next page of JSON data. Well, how are we going to know when to do that? Well, in order to do that, I'm going to put a new print statement in cell for row@ just to illustrate what's going on in here. I'll say print, and in between the quotes, I'll say string interp indexPath.row. That's going to show me the current indexPath.row of the cell that we're setting up to display. Remember, cell for row@ sets up cells to display either recycling cells that have already been shown or creating new ones. And I'll say of creatures.creatureArray.count. That'll tell us the total number of elements in the array. Now I'm going to build and run, and as we scroll down through this, when do we need new data? When do we need to get our next page of data? Well, that'll be when the indexPath.row equals the last value in the array that we've got. That would be creatures.creatureArray.count. Let's illustrate this in the executing app. So here we go. Down in the console, we see that we've called cell for row@ for 15 of our 20 cells. Now we're not yet showing all of those cells. It looks like iOS has cached some of those cells. We can't see them. They must be off screen, but we haven't shown cells for all 20 Pokemon yet. We haven't shown all of our data. Now let's scroll. As we slowly scroll up, we can see that we're showing the cell for the 16th Pokemon, 17, 18, 19. Actually, 19 is the last one. We're 0 indexed, so indexpath.row 19 is the 20th Pokemon. But once we've hit this, then we're showing the last value in our array. We've shown all of our data. Once we reach this point, we want to make sure that we call creatures.getData. Now we want to make sure that the URL string we're going to use is going to get us that next page of data, but hey, it's already going to do that because we already took that next value and updated our URL string, so when we call getData again, it's going to get the next page of data. So the getData function is almost perfect. The only other thing that we need to do is right now we're just taking any of the data that we get and we're putting all that data into our creatures array. Instead, what we want to do is we want to append any new data that we get into our creatures array, so our creatures array continues to accumulate the new data we get each time we call getData. Now that we've talked through the logic of what we need to do, let's code it. And in my print statement here, just to make sure that things match up on both sides of the print statement, I'm going to add 1 to indexpath.row in this first string interp. I'll stop the simulator, close the debugger, and just after this let cell line, when we create our cell, I'm going to say if indexpath.row equals creatures.creatureArray.count -1. And now we want to continue to call getData as long as our creatures.url string is a valid URL. How can we check to see if creatures.url string is a valid URL? Why don't we just check to see if that value has the prefix HTTP? Remember, if we got back a null value, which was a nil value, that only happens on our last page of data. That means that we don't have any data left. On that last page, the next value in our JSON is what we attach to our URL string. If we got a nil for that, then we just set our URL string equal to an empty string. So to add the condition to make sure that we've got a valid URL string, we'll say ampersand creatures.url_string.has prefix, and then in between the parentheses we'll pass in the string HTTP. Open and close curlies, and if both those things are true, we're going to call creatures.getData. Let's head up to view_did_load. We'll copy that whole creatures.getData block, and we'll paste it down here in the if clause. Now our final update is in creatures.swift, and remember, we need to make sure that any results that we returned are added to the creatures array. They don't replace what's in the creatures array. So we'll scroll down here into our do catch, and we'll set self.creaturesArray. I'm just going to copy this, equals, and then it'll be self.creaturesArray plus returned results. This will make sure that we're accumulating our returned results into creatures array. We're not just replacing our creatures array. So now let's build and run and see if we got that Paged JSON happening. Build succeeded. Hammer time. No errors. Here is our app. I see a screen full of Pokemon, but that's what we had before. Let's start scrolling. Look at down here in the console. 16, 17, 18, 19. Moment of truth. Oh, look at the numbers change down here. Now we've loaded another page full of data. That second value is 40 because our creatures.creatureArray.count is now 40. Let's scroll and see them. And look at them all in here. Number 25, Pikachu. He's a detective. What happens if we keep scrolling? Look at that. We load another page. Scroll again. Another page. We scroll all the way to the end. Let's keep going. There's an awful lot of Pokemon we gotta go through. Oh man, gotta catch them all. That's a lot of Pokemon to catch. But here we are, right down to the end. Sure enough, we've loaded all 964 Pokemon. Nice work, Swifter. In the next video, we'll learn how to load them up all at once, and we'll learn how to work with recursion. Keep at it.